3, 2, 1. We are live.
Okay.
Hello, Mike. Hello, everyone.
Hey, Caio. Hey, everyone.
Thank you for joining us in this live session. In this free series, we are covering the basics of how to build iOS apps with Swift, TDD, and a clean and modular architecture. So you will learn the strategies in your journey to become a black belt senior iOS developer. And that is to achieve technical excellence and be part of the highest paid developers in the world. So subscribe to the channel now and don't miss out on new episodes. All right. And in this episode, you will learn once and for all, all the differences between dynamic and static frameworks and libraries. So ways to organize your code base into modules.
Awesome. An obscure topic.
And these free live sessions are only possible because of the students of the Essential Developer Academy. So thank you very much for your support throughout the years.
Thank you.
And this is how this session is going to work. We'll go fast and we have a quick Q&A session at the end. Is everything working correctly? Can you hear us? Can you see us?
Yeah. People are saying hello. Hello, guys.
Awesome. Hello, everyone. Fantastic. All right, let's start. So in this series, we implemented a pretty clean, modular, and flexible code base. And we separated into layers here in the diagram.
Mm-hmm.
Each color represents a layer. We have the quiz engine, which is very generic. As you can see, there are no arrows from the quiz engine to any other layer.
Yes.
The quiz engine is generic. It's agnostic of any game-specific logic, user interface, presentation, whatever. It's an engine that can be reused to build any quiz game. Then we have the game-specific logic here in the scoring layer, where we have this algorithm to calculate the score, and also the builder to preserve the invariance of the quiz structure, the data.
Mm-hmm.
And of course, this layer also is not coupled with any other layer, because this is the core of our application, the core logic.
Awesome.
Which means it can be reused by different applications. You can use the same logic in other applications with different UI, with different presentation, with a different engine as well.
Exactly.
So these two modules here, scoring and engine, they are absolutely independent.
Yes.
And then we have the presentation layer. The presentation layer now depends on the engine where the question lives.
Mm-hmm.
Right? So it depends on this framework. But it doesn't depend on the UI, which means we can have different UI implementations. Like here we have the Swift UI implementation that uses the presentation models and logic. And we also have a UI kit implementation with view controllers using the same presentation, the same scoring, the same engine. Everything is the same, just the UI and navigation changes. And that's the power of modular code bases. You can easily replace frameworks and volatile dependencies without breaking every other module.
Yes, exactly. Fantastic.
So far, we kept all those types in a single project. Let's have a look at Xcode. Boom. Here we have the quiz app project, and we're just separating here with folders. We have the scoring folder with those types we showed you, then the routing, presentation, UI, and the main layer where we compose all the modules. The only thing that we separated in another project is the quiz engine that can be reused across applications as well. But everything else is still in the same project, so it's a choice. If you want to reuse the scoring logic in another app, then we can extract it to another project because it's completely decoupled. All the types here, they don't reference any other component from other layers. Make sense?
Yes, absolutely.
We can extract this logic to a reusable module. But how? Well, one way of reusing this logic in another application is to copy and paste it. But then what happens?
We're gonna have to reference that somehow, and of course, we're gonna end up with 2 copies of the same code. That's not good.
Why not? Every time you change something, you need to change it in every copy.
Exactly, duplicate state.
You know, of course, that's not the best way. Copy and paste is not the way to share code.
Absolutely.
That's where you start thinking about modules. Here, from the Swift book by Apple, a module is a single unit of code distribution, a framework or application that is built and shipped as a single unit and that can be imported by another module with Swift's import keyword. Fantastic. So the idea is to create a framework or a library where you keep your reusable logic. So it's easier to maintain it without duplicating code.
Yeah, exactly. Just like we did with the quiz engine framework.
Absolutely, like we did here with the quiz engine framework, which lives in another project. And inside that project, we have a framework target for the quiz engine code. Make sense?
That's it.
And the quiz app has the quiz engine framework as a dependency. As you can see here in the setting, in the quiz app target, application target, we import here the framework. And that's how we link them, this dependency, into our quiz app.
Exactly.
And when we want to use any type that is defined in the quiz engine, we need to import the quiz engine, which is the types live in another module, the quiz engine module. So we need to import the quiz engine module.
Exactly. And as we depict in the diagram, the dependencies, the arrows, they don't come from the quiz engine towards the quiz app, the main module, the scoring presentation UI. No, it's the other way around, right? It's the quiz app modules depend on the engine, right? So this is how you can represent the dependencies visually in a diagram.
That's it. So the engine does not depend on the specific application, which means it can be reused across applications. It's just a framework target. Make sense?
That's it.
And you can do the same, exactly the same, and create different modules for each layer in your application. But won't it be hard to maintain my project with many targets, frameworks, packages, and so on? For small projects, you can keep everything in the same project and repository as we showed here. But you need discipline to keep your components decoupled and separated into layers, like virtually, because there will be no physical separation between modules. And if you keep this separation, once you need to reuse it somewhere else, then you can split into separate targets because your code is already modular. It's just everything bundled in the same project. Make sense?
That's it.
But for larger projects, Modules will make it easier to work in the code base, because you can make localized changes that won't affect or conflict with other developers that are working in the same code base. You can speed up the build and tests as well, since you only need to run tests, to build and run tests related to the module you are working on.
Yes, exactly. That is a very, very important trait.
And if there's any slow manual task, for dealing with the modules, like for creating a new module, for separating code, then for linking them, you can automate it. There are a bunch of tools that can automate this integration, creation and separation and linking of those separate modules. For example, you can write your own script or use tools like SPM, the Swift Package Manager, or Carthage, CocoaPods. There are tools for that.
Exactly. And the other common question is won't my app be slower if I have a bunch of frameworks? It wouldn't be slower to start if I have a bunch of frameworks.
It depends. It depends. There are different kinds of frameworks, there are different kinds of libraries, right? And then performance-wise, size-wise of your application, it will depend if you're using dynamic or static libraries. So you need to make this choice when you're creating these separate modules, because whatever problem you see at the moment with modules, it can be solved. You can still take the benefits of modules without the headaches. Because the wrong way is to neglect modules because you believe it will slow down your team or slow down your app or make your app bigger, when it will not. Make sense?
Yeah, it's exactly the opposite. What is going to make your app slower and the whole development process slower is not organizing your project, not taking the time to, figure out your needs and organize in the way you should.
Absolutely. If you don't organize your project, you'll take much more time in the long run. Every developer will get in each other's way.
Yes.
The build and the test will get slower and slower the larger the project becomes. And there will be a lot of duplication as well, leading to a mess.
Yes.
And so on. So, of course, we know that when we organize things, we can be much more efficient, right?
Mm-hmm.
So that's why we create modules to solve those problems related to code organization and distribution. And you can create frameworks or static libraries. For example, when you create a new target here, you have the choice. For example, I'm going to create a macOS or an iOS, say, framework. Or I can choose a library, right?
Mm-hmm.
Static library. And we typically use frameworks because we find it easier to manage, and it allows you to share more than just code.
Mm-hmm. Exactly. In a framework, you can bundle resources like fonts, images, string files, nibs, storyboards, of course, along with the source code, right? And the dynamic and static libraries as well.
Exactly. Like framework is like a folder. It's like a bundle.
Mm-hmm. Yeah.
That will contain your libraries, either dynamic or static, plus resources. Resources, like even your core data models will be there.
Mm-hmm. Absolutely, yes.
But static libraries can only contain code. They cannot contain resources, right? What some people do to embed resources into static libraries is to encode it. For example, in base64 representations, and embed it in code as a string, and load it at runtime. This is one way you can do it. Or you can create a bundle. Mm-hmm. A bundle type to accompany your libraries. Because then you can add resources to these resource bundles, like storyboards, xibs, string files, localizations,
Yeah.
And then you need to ship them together, the bundle and the static library. But with frameworks, you can ship both code and the resources. So the framework will act like a bundle.
Yep.
For your code and your resources together. Make sense?
Absolutely.
And you can load resources from your bundles, either with a framework or with the static library resource bundle, with the bundles API. NS bundle or just bundle.
The bundle, yeah.
When you use a bundle, you have the main bundle for your executable, but you can also load bundles with an identifier. So when you create a framework, you set a bundle identifier.
Yes.
Here. And that's how you can load stuff from your bundle. You can also create a bundle for a given class. If that class is within another framework, you will find the bundle for that class. You can load resources from that framework bundle or the resource bundle that you create with your static libraries as well. But if you're using static libraries and the resource bundles as a separate thing, it requires some extra work. That's why frameworks are usually easier to manage. So let's have a look at the Quiz Engine framework type. You can go to Build Settings and search for Mac O type. As you can see, the Quiz Engine is a dynamic library. So it's a framework that contains a dynamic library. So the code will be built into a dynamic library.
Okay.
Plus its resources. But we can choose here. It can either be a bundle, it can be an executable. So executable is for applications. For example, the quiz app target or any iOS app is an executable. This is what determines the type of your target here, the linking. Here it's an executable, but our engine is a dynamic library. And it can also be a static library.
Okay.
So frameworks can have either dynamic libraries or static libraries within it.
Okay. And the difference here being that dynamic libraries are linked at runtime using a dynamic linker, while static libraries are linked at compile time. Right?
That's it. Static libraries are linked at compile time.
Okay.
Dynamic libraries at runtime using the dynamic linker.
Right.
Static libraries linked at compile time with the static linker. So regarding performance of your app, static libraries can be faster because, well, performance of starting your app, for example. Static libraries can be faster because you skip this dynamic linker phase that you need to do at runtime. So if you start your app and you load every library, every dynamic library at once, it's going to slow down the start time. But a static library will lead to larger binaries because it's going to include all the static libraries code within the binary.
Exactly.
So let's see it in practice. I created 4 builds of this application, the quiz app. One that embeds the quiz engine as a dynamic library. Another one that uses the quiz engine as a dynamic library but doesn't embed it. Another one where the quiz engine is a static library. Another one where the quiz engine is a static library and it's embedded in the app. When you link here a framework, you have the option to either embed and sign, embed without signing, or do not embed. Now you're going to understand why this exists. Why this exists. All right. Let's have a look here. First of all, the size. Look at how the size changes. The same application, but the size changes depending how we link the quiz engine dependency. Look at that.
Okay.
So the smaller app size is if you don't link or don't embed the dynamic library, or if it's a static library not embedded. The largest one is a static library that is embedded.
Okay.
Let's see why. Let's open here our application. You can just open, show package contents, and there it is. So here is the dynamic library, the quiz engine framework as a dynamic library, and it's embedded in the project. Look at the difference if you don't embed it. Can you see the difference?
Yep.
When you embed it, you have a frameworks folder. Inside this frameworks folder, you're going to have all your frameworks that are embedded into your application. Here we have the quiz engine.framework. As I said, it's just a folder. A framework is just a folder structure, a very structured way of bundling your dependencies. As you can see, it has the info p list of our framework that contains here the bundle identifier and all the details about the framework. And we also get here the dynamic library, the executable. So look at the app size. This is our application, quiz app. And here is the quiz engine executable, the dynamic library. Look at the app size, the binary. Whoops. Let me bring this back here. Look at the app size. 1.2 megabytes. And 100K, 173K for the quiz engine. And when you run your app, at runtime, when you access the quiz engine, when you import the quiz engine, when it's needed, you will load and link with this binary here at runtime with the dynamic linker. Make sense?
That's it.
Now let's have a look at the static library. Look how the binary size of the application is larger, 1.3 megabytes compared to 1.2, because it contains the quiz engine code inside this binary. It links it statically, with the static linker in one binary. So all the library code is added to the same executable. It's not loaded at runtime. It's there statically in the same executable.
You'll mention that there is no frameworks folder exactly because of that in this case.
Because it's not embedded. Make sense? So what did I do? So what I did here for the static library, I changed this to static library, and I removed the embedded. Do not embed. Why? I don't need to embed it because it's already embedded into the application here. All the source code of the library is compiled here with the application. It's linked statically at compile time. Now I can also embed the static library by selecting embed and sign, or embed without signing. And now we have a larger binary plus a framework, which makes my application much larger. That's why it's 1.5 megabyte, the application.
Right.
But it's unnecessary to have the quiz engine here because it's already within the executable. But now we have access to resources as well in the quiz engine framework because we have a bundle. But without a static library, doesn't have a bundle framework. Make sense?
Yep.
So if you have resources, it needs to be bundled with the framework, but you don't need the quiz engine here because it's already added to the executable. It was linked statically at compile time. Make sense?
That's it.
All right.
It tends to make so much more sense, actually, when you see the sizes, when you understand, okay, do some very simple math and say, yeah, maybe the framework is included in the binary or not, So I quite like that.
Now, what about the dynamic library that is not embedded? It's not, the library is not within this binary, and it's not available here. What's going to happen when I run this app? It's going to crash. The linker, the dynamic linker, is not going to find the framework there. So it's going to crash. You won't be able to link the quiz app with the framework, this dependency. So it's going to crash. Have you ever got a crash saying like, couldn't find library at our path? That's why.
Yeah.
That's why, because you cannot find it. What is it? Where is it? It's not here in the binary. It's not outside. You cannot link it. At runtime, it's going to crash. It doesn't have all the dependencies. Make sense?
Mm-hmm.
So what is the benefit? Why would I want a dynamic library? What are the pros? Well, if you have a dynamic library like this that is not embedded in the application, that is loaded at runtime, it means that if you have module stability that we do now in Swift, right? You can replace this framework with a new version, with an update, without recompiling and redeploying your application. As long as it keeps the same public interfaces, that's it. For example, system frameworks like Core Data, you don't need to embed it into your application. They are linked dynamically. So Apple can release iOS 15 tomorrow with a new version of Core Data, with new updates. As long as they don't break the APIs, they just replace this framework here, this binary, and we don't need to recompile, redeploy this application. We just switch this framework with something else. Also, Core Data can be reused across applications. You have only one, you can save disk space because you have only one Core Data binary that is used by all applications. Make sense?
Mm-hmm.
We have one dynamic library that is reused across applications. Remember, before ABI stability, every Swift application would be shipped with the Swift runtime embedded in the application. So the binaries were much larger.
Yeah, exactly.
But now with ABI stability, with module stability, we reuse the Swift runtime that is running on the device that is shared across all the other applications. This way, we have much smaller binary sizes. So dynamic libraries can lead to smaller binary sizes with the system frameworks. Make sense?
That's it.
But what is the problem with dynamic libraries? The problem is that if it's missing the framework in there, your application is not going to run. If there's a system framework that is missing, if there's a dependency that is missing, it's not going to run. It's going to crash. So one pro of the static library is that you are sure, 100% sure that the dependency is always there because it's linked directly at compile time here in the binary. All the dependencies are there, which makes it binaries larger. So that's the difference between static libraries, dynamic libraries, frameworks, and if we embed or not embed. What about signing?
When do you need signing? Yeah.
If you already signed your framework when you built it, you don't need to sign it again. Otherwise, you need to sign the dependency that is not signed. Simple as that. If your framework's already signed, you don't need to sign it. Otherwise, you need to. Make sense?
Yep.
That's it. Other benefits of dynamic libraries is like, I don't know, if you distribute code like Realm, which is a proprietary software, you don't have access to the source code, right? You just distribute it as a dynamic library that can be replaced as well with a new version without breaking the binary with module stability. So that's it. Those are the differences. And you can see it. You just build your app with different settings and you can see all those differences in there. Make sense?
Yeah, absolutely. Fantastic. Just like one of those things that yeah, as I said, it's obscure and it's hard to find good documentation, and it's probably, like, you can have a whole career as an iOS developer and never touch these subjects, and you do whatever you have to do, to make it work, and that's it. You don't want to go back and fiddle around, most probably.
Absolutely. So you don't need to embed static libraries. They are already linked at compile time. But you may have to embed the resources of your static or of your framework that contains the static library. Mm-hmm. If you have any resources there, like here I added a test nib, Mm-hmm. It could be a storyboard, it could be some translations, and so on. So that's it. I'm going to change here. Then the quiz engine only has code, right? It doesn't have any resources. It doesn't have storyboards, core data models, and so on. So I'm going to keep it as a static library. Mm-hmm. And I'm not going to embed it anymore. Because now we get the best of two worlds, right? We're going to have a larger binary size, but we're not going to have that embedded framework. So overall, we're going to have the smallest application size for this use case. So your task today is to look at your code base and look for areas that could be modularized.
Awesome. Okay.
They would benefit from modules. Is there any duplicate code across modules or across apps in your application? Are you wasting time building and running unrelated tests for every small, tiny change? No, are your frameworks set up correctly as a dynamic or static library? And are you embedding a framework that shouldn't be embedded? Or are you not embedding a framework that should be embedded, and so on? Because this is going to make your apps run faster or be smaller or run and not crash.
Yes.
All right. So that's it for this live session. We covered modules, dynamic and static libraries and frameworks. Those are essential topics if you want to become a black belt iOS developer and be one of the highest paid developers in the world. And we hope this session helps you better develop, test, and maintain your code bases. And we're going to cover so much more. So if you enjoyed this session, like the video and subscribe to the channel so you don't miss out on future episodes. Now let's have a quick Q&A.
Okay, I have a bunch of questions.
Okay, let's see.
So the most popular question ever, which software do you use for graphs? Yeah, we use, yep, we use draw.io.
That's it, draw.io.
Okay.
What else?
Arifin asks, how small is a small project? Well,
you have to answer this question, I believe.
Exactly. You are the one who's going to define that based on the on how the team operates.
If you're working alone, that's probably a small project. Mm-hmm. But you can still benefit from separating things into layers. You can keep still in the same project, right? You can still keep everything in the same project. If you're working alone and it's a small project, you don't have issues. Like you build a project, you don't feel like it's slow. You run the tests and they finish like in seconds, like in 0.1 seconds. That's fine. If things start slowing down, then you can start thinking how to redistribute this. If you start onboarding new people into your team, then you start separating things to organize better so you don't get on each other's way.
Absolutely.
What else?
Javier asks, do you recommend to start your project in a modular architecture since the very beginning, or when the code base or team is big enough? Right. So we touched this subject in the past. What we recommend is start small, use good principles, and modularity is going to be there whenever you need it. No, you don't have to break down everything in, like a bunch of frameworks and libraries. But the point is, if you need that, it should be very, very easy to do. So the cost is very small.
The idea is do it when it's easy. Do it when it's easy, because when it's hard, it's going to be hard.
Yes.
So in the beginning, you don't need to separate everything into modules, into targets, into projects, into Swift packages. No. But virtually, you will already start designing your application to have, in the core of the application, the reason why your application exists, the domain, the core logic. Then you may create some generic engines that you can reuse across application. Then you're going to have your presentation logic, your UI logic, your networking logic, and you're going to start organizing them in separate modules, because it doesn't cost more in the beginning, especially if it's simple. So do it when it's simple. So when things get harder, you're ready. The hard thing is if you wait until things get harder, maybe you're not going to have the time or the resources to do it. So I'm not saying make your code base more complex. No, this doesn't make your code base more complex. It makes it simpler to maintain now and in the future. Choose simple solutions that scale. Make it more complex only if needed. Make sense?
Mm-hmm.
What else?
Hassam asks, why should I use static libraries when I don't have any resources?
Where is it?
Hashem, why should I use static library when I don't have any resources?
Why should I use static library when I don't have it? No, you can use static libraries with resources as well. You just need to put the resources in a resource bundle.
Yeah, maybe I'm not sure, Hassam. If you mean something else, please let us know, because this is an interesting one for me. I don't know if that answers your question.
I prefer frameworks. I find it easier to manage and link them. So if there are no resources, should I go with static library? Yes. If you have no resources, static libraries within a framework, even if it's a framework, you can set the Mac O type to static library. What else?
So
static libraries, like, they can make your app faster to run the start time, because they don't need to do the dynamic linking phase, right?
Yeah.
But remember that a dynamic library is loaded when needed. So if you have frameworks that you don't use in the beginning, like when you start your app, they're only going to be loaded in the future when needed. So it may actually be faster with a dynamic library, because you don't need to load this huge binary that everything is linked statically. But if you start your app and you load all your dynamic libraries at once, in the app delegate, you start Firebase events, you start tracking Google Analytics, you start all those core data frameworks and so on, then your startup time might be slower. But if things are loaded as needed, then gradually you're not going to have that performance penalty.
Yes.
So it depends. If you're not distributing this code as well as why not? Let's see. How can you update the quiz engine without updating your app in the App Store, you cannot. In iOS, you cannot update just the framework. So you don't get the benefits of dynamic linking because you cannot just replace one thing. You don't have like partial updates. Every time you're going to update something, you need to re-download the whole thing. And that's a problem in the iOS App Store, right? Because you don't have like gradual updates. For example, Xcode, 3 gigabytes, I don't know, 10 gigabytes. If they change one line of code, they cannot just ship that one line of code change. That will be like 1K. They need to ship another 10 gigabytes again to the customers. And that's how they do the process, right? But the benefits of dynamic linking you have at least in the system libraries. Or if you're distributing your apps somehow outside the App Store.
Yes.
Like Mac apps.
Matt has an interesting...
Wait, okay. Swift package versus frameworks. So I find it easier to manage frameworks if everything is here in the same repository, the same workspace. But a Swift package now, you can distribute your frameworks across repositories. They can live in completely separate repositories. On GitHub, for example, you can have different repositories, and Swift Package Manager is going to deal with like fetching those repositories and linking them and updating them when needed. So if I have code distributed across repositories, I'm going to use Swift Package Manager. Otherwise, I'm probably going to use some more lightweight frameworks. Should we choose static libraries for faster startup times? I already replied to that. It depends. But overall, probably. But you need to measure before optimizing. I've missed almost the entire video. Will it be available somewhere else? Yes, YouTube, Essential Developer channel. I think that's it.
All right.
Do you see any other questions related to
it's so many comments and very interesting stuff that you're saying here, but of course we can't read everything.
I think that's it.
Yeah. Awesome.
Awesome. All right, so that's it for this live session. If you want to take your dev skills to the next level and support our work, we are running a free crash course in January 2021. Visit academy.essentialdeveloper.com and sign up now. Thank you for watching, and we'll see you again next time.
Bye, y'all.
See ya.